For number 1, you should have divided everything by 6. So that would have given you -1 is less than or equal to A, which is less than 5. Then you could have drawn this on your number line, a closed circle at -1, an open circle at 5, and a line to -1. If you drew arrows pointing the opposite way, that was not an and inequality. This was worth 3 points. The work for this answer and your line or your inequality graph. Do you have any questions on 1? For 2, you had to solve both of these equations because they were OR. Add 3 to the side. So we have 4x is less than 0. And divide both sides by 4. So you have x is less than 0. I'm going to go ahead and draw that now. Open circle to the left. And then on the other side, we would need to get rid of 3. Some of you did this a little differently, but as long as you did the steps correctly, that's fine. So if I subtracted -3 on both sides, I'd have -2x is less than -4. Divide both sides by -2. My sign would change direction, so it is now x is greater than +2, and you need an OR in between them. That would be an open circle at 2 going to the right. Do we have any questions on that one? Number 3 was another OR inequality. So on the left, we would need to add 5 to both sides. So we'd have -b is less than 3. And then get rid of the negative by dividing both sides by -1. So b is now greater than, the sign would change, -3. That would be an open circle going to the right. And then for the other, we would subtract 6 on both sides. So 4b is less than or equal to -20. Divide both sides by 4. So b is less than or equal to -5. That would be a closed circle going to the left. And we need to make sure this says OR. Numbers 2, 3, and 4 were worth 4 points. The work for each inequality, your final answer, and your graph. So your graph was 1, your answer was 1, then the work was 2. Do we have any questions on that one? Tiffany?
It's not on this one in specific, but I have a question about the sum. Oh yeah, I guess. When it's when you're dividing by a negative, does the sign flip? Is that the only time it flips?
Multiply or divide by negative.
Okay.
To both sides.
Okay.
Yes, ma'am.
How would you graph an and?
They would graph together. There would be a line in between them. Number 4.
I wasn't sure because you said that. I thought you said it wasn't.
These ones weren't and inequality, but this one was. For number 4, you had a bunch of things you had to move to the other side. So let's say I moved my 2k over to the left and my 5 to the right. I have -5k is less than or equal to 0. And then I could divide both sides by -5. Some of you did this the opposite way, and that's fine. This would then be k is greater than or equal to 0. So that would be a closed circle at 0 going to the right. And then on the other side, I'm going to move 4k to the left and then 2 to the right. So subtract 4k, add 2, so we get negative 2k is greater than or equal to 8. Then we could divide both sides by negative 2. K is now less than or equal to negative 4. So that would be a closed circle to the left with an or in between. Do we have any questions on that? Forgot, did you have a question?
I don't know, I kind of did like,
I think it was because of the missing variables. So when you're subtracting things, like here, you're just subtracting numbers. But here you're moving constants and variables. So when you're moving variable terms, they should have variables in them. Any other questions on that one or this objective in general? Anyone still need number 4? The next objective. These were either all 8 equals 1 trinomials or you had to factor out a DCF first. So with 5, you're looking for 2 numbers that multiply to be negative 15 but add to be 2. The 2 numbers that would have worked are positive 5 and negative 3. From there, you could have went straight into your factors. M plus 5 and M minus 3. No, it doesn't. So if you do M minus 3 first, that's fine. Questions on that one? Other questions? Number 6. This one did have a GCF, 5. So we can divide 5 out of everything, and we have n squared plus 2n plus 1. So then we're looking for 2 numbers that multiply to be 1, but add to be 2. The only numbers that would work are 1 and 1 if they're both positive. That would be 5 times n plus 1 and n plus 1, or 5 times n plus 1 squared. Either of these answers will fine. Marta.
What did you do to get the 1 and the 2?
Here. Divided everything by 5.
Okay.
Do we have other questions on that? Many of you saw the number in front and started factoring using the a does not equal 1 method, which is fine, except at the end, many of you got something that said 5n plus 5. That should have told you that you need to factor that again. Factor out a 5, that way you have your DCF and your n plus 1, and then your other n plus 1. For number 7, we can divide each of these by 2. So if I do that, I'm left with n squared plus 2n plus 1. If you look, these are the same. That may not happen on the test, but this did happen on the quiz. So that means the numbers are going to be the same. So your factors are going to be n plus 1 and n plus 1 again, or 2 times n plus 1 squared. So that was pure coincidence that it happened. Here or here? This one. If I'm dividing 2 by 2, I get 1. Other questions on that one? Yes.
So, I got it. Like, like I used to
So you could have done it that way, so I'll do it for this one. So if I multiply 2 and 2, I get 4 and then 4. So two numbers that would multiply to be 4 but also add to be 4 would be 2 and 2. And you have 2n squared plus 2n plus 2n plus 2. This should tell you that you need to factor out a GCF. But if you didn't do that, you could keep going. Of these two, 2n is what they share or have in common, so I could divide out a 2n and get n plus 1. These two share a 2, and what would be left was n plus 1. So you'd have 2n plus 2 and n plus 1 as your final factors. But this can be factored again, because these both share a 2. So either way you did this, you should have gotten the same answer. Is there a Number 8. You were looking for two numbers that multiply to be 15, but added to be negative 7. 8. I wrote that on you guys' paper. The two numbers that would work are negative 5 and negative 3. So m minus 5 and m minus 3 for your answer. Kobe. In this case, because this is positive, the only way we multiply to get a positive, they either both have to be positive or both have to be negative. If one is negative, then 15 would have to be negative. On back. With number 9, we would need to multiply, well first, see if it has a GCF. This one does not. Then multiply 2 and negative 20. So you need to, before I continue, each factor you got for the last section was worth a point. If it had a GCF, that was worth an additional point, so that the total was 10. For this, some are 6, some are 7, but I'll talk through that. So two numbers that multiply to be negative 40, but add to be negative 3. The two numbers that worked were negative 8 and positive 5. Some of you got those two, but switched the negatives or made them both negatives, which changed your answer. Doing this process in whatever way you did this, that was worth 1 point, so I could see how you got these numbers. Rewriting this into 4 terms was worth 1 point. Finding the GCF of the first two, and then finding the GCF of the second two, those were both worth 1 point. So 2R, or if you switch them, just R. R minus 4. And 5. These were both worth 1 point. And then both of your final factors, 2R plus 5 and R minus 4, were worth 1 point apiece. So that total was 6 points. 1, 2, 3, 4, 5, 6. Do we have any questions on that one? For number 10, there was a GCF. So I have this listed out both ways. You can either do this without the GCF or do it with the GCF and get it at the end, but you had to still get it. GCF first. So if you did a GCF, this would be 4R squared minus 4R plus 1. And then we're looking for two numbers that multiply to be 4, but add to be negative 4. The two numbers that would work are -2 and -2. So 2 times 4r squared minus 2r minus 2r plus 1. And then we could keep going. So bring down your GCF. Some of you were not doing that, and then you lost points from that. GCF of these two were 2r, leaving 2r minus 1. GCF of these two was -1, leaving 2r minus 1. And your final answers, this GCF 2, this factor 2r minus 1, and this factor 2r minus 1 again. Or 2 times 2r minus 1 squared. Either or. So that one was worth 7 points because you had to factor out the GCF. Do we have any questions on that? Scrolling down to 11. This one did not have a GCF. So we're looking for two numbers that multiply to be 48, that add or subtract to be -49. Remember, the closer these are, one of your answers is going to be 1 or -1. It was -1 and -48. 48 is what I meant, but I wrote 49. And then you could rewrite, split the middle, find a GCF. Some of you were changing the T's to R's. Don't do that. Leave them as T's. So minus T minus 48, T plus 8. Of these two, your GCF would be T, leaving 6T minus 1. Of these two, your GCF would be -8 because this is negative, leaving 6T minus 1. And your final factors would be T minus 8 and 6T minus 1. Have any questions on that one? And then the last one. These each can be divided by 3. So if you did that, you're left with 5y squared minus 6y minus 8. And then you're looking for two numbers that multiply to be -40, but add to be -6. -10 and +4 would work. And then we could start that process. Rewrite this into 4 terms. And then split the middle from there and find your DCF. So of these two, it was 5y, leaving y minus 2. Of these two, it was +4. So our final answer was 3, 5y plus 4, and y minus 2. So total, this was 26 points. 2 of them were 7, 2 of them were 6. Do we have any questions on that one? Your test is going to be set up similarly with the same amount of questions, and we will start that when we get back from lunch.